Question number 6 says, two identical charged spheres suspended from a common point by two massless strings of length L are initially at a distance d apart. So let me just make a diagram so that this becomes quite clear to us. So let me just draw a diagram. This is our, let's say, rigid support, and from this support there are two strings attached with which there are two spheres like this, correct? Now these are two charged spheres, okay, there are charges are residing on them, and the separation between them is d. So let's take a separation between them, okay, this is our separation between them, that is d. Okay, great. Now they are saying the charge begin to leak from both the spheres at a constant rate. So both of them are leaking the charges, means charges are going away from these two spheres, okay. As a result, the spheres approach each other. Obvious it is. Why they will approach each other? Because initially they are repelling each other because the charges are equal. Now when the charges are leaking, the charges on both the spheres A and B is decreasing. If the charge is decreasing, they will do what? They will attract each other. Why they will attract? Because the charge becomes lesser and lesser stronger, repulsive force will become lesser and lesser. So it becomes weaker, right? Now what happens, question is asking, as a result the sphere approaches to each other with velocity v. Obvious it is, they will move. So where there is a motion, where there is a change in distance or displacement, there will be velocity, right? Then v varies as a function of the distance x between the sphere as. So we have to find the relation between, okay. Let me repeat the whole question so that you can understand it better. We have two spheres, they are completely charged, A and B, similar charges, right? Why similar charges? Because they are repelling each other, right? And the question itself is saying two identically charged. Identically means same charges. Let's call this charge as Q over here and Q over here. Okay, great. Now they are suspended from a common point. Let's say this is the common point over here. Okay, great. With the two massless strings, okay, that is length L. So let's say this is length L. Sir, why massless? Because if the strings will have mass, you will have to consider the mass of the string as well, right? Great. Next is, are initially at a distance d apart. Now charges started leaking from both A and B, so they will slowly come closer. So let's say they come closer like this at some certain point, they reaches here, okay. So when they are coming towards each other, their distance between them decreases and eventually velocity will vary, okay. Let's start figuring out, okay. So before we find this, let's find what are the forces acting on both of them. So let's consider the A. On A, there is a repulsive force due to B in this direction. Similarly, B is repelled in this direction, correct? Repulsive force is always along the line joining the two, right? What is the force acting on A due to the gravity? That is the weight. So that will be mg over here, correct? Weight is downward. So if weight is downward, mg is downward and Fe is there, let's find the resultant. So we know that the resultant due to both of them will be somewhere here, correct? If two vectors are acting like this, the resultant will be in this direction, right? Okay, let's join them and let's imagine that from the center, okay, this is a line joining, so this will be d by 2 and this is theta. What is theta? Read the question carefully. D is very, very less than L, so theta is very small angle, okay. So that is d by 2, this is also d by 2, the separation whole thing is d. I hope this is clear. Now look at two triangles. Which two? Let me join this one, okay. So let's just make this one as little small, okay. So here it is, let's make it like this. So look at this triangle over here and this triangle. In both the triangles, this is vertically opposite angles, correct? This is over here 90 and this is over here 90, both are 90 degree. The third angle has to be equal, so this will be angle theta. I hope this is clear. Clear? So one is theta, okay, and okay, another one is 90 and third is vertically opposite angles. Let's take this triangle. Let me call this triangle, A is already name given here, let me call it as P and let me call it as Q. So let's take triangle APQ. In triangle APQ, what will be your tan theta? So tan theta is always perpendicular over base. So if you take a triangle like this, right angle triangle, and this is angle theta over here, then theta with the side is base and the opposite one is perpendicular, right? You can, if you remember it like opposite or adjacent, okay, you know that opposite upon adjacent is tan theta, right? So here the opposite is how much? That is our force Fe, and because this is our force Fe, AP is force Fe. So if you are confused, let me just write here first in terms of triangle sides, AP vector upon our PQ vector, right? So AP vector is nothing but electric force Fe, and PQ vector will be nothing but weight mg. So tan theta will be this. So what will be, let's write here in proper way, tan theta is nothing but electric force F upon mg. This is our equation number 1. Great. Okay, great. So if this is that, let's understand what is tan theta from another triangle. Let's call it as O and let's call it as X. Look at that from triangle AOX. What will be now tan theta? Tan theta will be equals to what? Perpendicular over this side, but this side who will calculate? Let's calculate this side, okay? That is L, that is d by 2. So tan theta will be equals to how much? That will be L d by 2, whole divided by root under L square minus d by 2 whole square. Let me repeat again. If I draw this triangle over here, which triangle, in case if you have not understood, that is XOA. Here is the angle theta, this is side L, this is d by 2. What will be this? Using Pythagoras theorem, L square minus d by 2 whole square. So perpendicular will be, or the opposite will be d by 2 here, and the base will be this, correct? So we will substitute here. So this will give you how much? D by 2 root under L square minus d by 2 whole square. Correct it is? This is tan theta. Okay. Now we can also use, since the angle theta is very, very small. Why it is small? D is very, very less than L. So in that case, small angle approximation says this is also equal to theta. Correct it is? So tan theta will be equals to, nearly equal to theta. Or you can also write sin theta also you can take. Okay. Or instead of taking sin theta, we can take that L. If that theta is very, very small, this factor will be reduces to 0. Okay. Or you can take sin theta also and put it equal, that's your wish. So this second parameter will reduces to 0 and we will left with L square minus something will remain L square. So you will left with d by L. Clear? That is tan theta. Okay. Let's say this is our tan theta. So we will make use of this. This is our equation number. Okay. I hope this is clear. Let's say at any instant, listen very carefully, at any instant, these two sphere balls were somewhere here in between like this. Then this theta will be much smaller, right? Okay. In that situation, and instead of taking it as d, let's call it as x. The separation between them is x. So this will be our small angle approximation. We can make it as theta will be equals to x by 2l, because the distance, the separation between the two will be x. So this is our equation number 3. I hope this is clear. You can keep it tan theta also. Let's recall our equation 1. So let me write it here. From 1, tan theta is also nearly equal to theta. So that will be x by 2l will be equals to force. At that instant when they are x distance apart, what will be the force between the two spheres? K, which is 1 by 4 pi epsilon naught. Charges on both the spheres is how much? Q square upon KQ square upon separation between them. That is how much? X square. And this mg is already there. So let's keep here mg as this. Correct? Let's cross multiply. It will be x cube. Okay. And that will be equals to x cube upon 2l is equals to k q square upon mg. Now listen very carefully. K is constant. Yeah. 1 by 4 pi epsilon naught, fixed value, doesn't change no matter if the charge is leaking or if they are coming close to each other. Mass of the sphere is changing? No, it's independent of charge. G value? No, we are on Earth only. We are not going anywhere on any other planet. The length of the strings? No, the length of the string is still same only. It doesn't like you are taking 10-meter wire and tying a thread and later on it becomes 2 meter. No. So all other are constants. Only two things are proportional, which you can see from this equation, and that is x cube is proportional to q square, or q square is proportional to x cube, whatever you want to write. Clear? So we can now differentiate this equation. On differentiation, this will be what? Okay, but before we differentiate, let's find here. Okay, so we can say q is proportional to, let's square root both the sides, x to the power 3 by 2. Now let's differentiate. So differentiation will give you dq by dt and this is proportional to, what's the derivative here? The derivative of 3 by 2, that will be 3 by 2, which is a constant, x to the power 3 by 2 minus 1 half dx by dt, because we are differentiating with respect to t. Okay, so this is our implicit function. So 3 by 2 is a constant. Okay, and dx by dt is what? V, correct? So we can say that dq by dt, let me write it here on this side, dq by dt is proportional to x to the power half into dx by dt is v. Clear? And if you take this x to the power half on the other side, v will be proportional to x to the power minus half. If you take it on the left hand side, x to the power half, it will be x to the power minus half, right? Okay, so this is the relation between v and x. They have not asked the relation between charge. Okay, so dq by dt is current. If they ask you the relation between velocity and the current, you can see that they are directly proportional, right? So here it is, v is proportional to x to the power minus half. So correct answer for this is option B.